We're now going to move on to part 2 of our coverage of the LockManager App case study's server structure and functionality. And this part of this case study is going to focus on the service class, the LockManager service, that's defined as part of the LockManager microservice using Spring Web MVC. The LockManager service defines quite a number of methods, some of which are called back by the LockManager controller. And the purpose of LockManager service is to implement a distributed semaphore using Java ArrayBlockingQueue. And we'll talk a bit more about what a distributed semaphore is here shortly. As you can see, there's many more methods here in the service than there were in the controller, and that's because we have a very sophisticated implementation that's pretty fun to talk about. As usual, we put an annotation that indicates that this class implements the business logic of our LockManager application microservice and enables auto-detection and wiring of dependent classes using class path scanning. There are two auto-wired fields that are part of LockManager service. The first one, shown here, mExecutor, is an AsyncTaskExecutor, and it's auto-wired to use the executor's new virtual thread per task executor. And we use that to run the deferred HTTP request processing off of the servlet thread that was called in the controller for acquire in order to be able to do the processing in a virtual thread to do the actual acquire service implementation. And you'll see how that's auto-wired and how it works here shortly. In particular, we have a bean that's defined in the server beans class in the common folder. And this bean, as you can see here, is going to create a new virtual thread per task by creating a task executor adapter that adapts the new virtual thread per task executor into something that understands how to play the role of an async task executor. So if you look carefully, you can see async task executor here is the matching type that this bean is creating down there. And we'll look at that when we look at the implementation in more detail. There's a second auto-wired field in the LockManager service called LockManager App that is used to associate a LockManager object with its corresponding ArrayBlockingQueue state information. So let's break this down a bit. Let's talk first about what ArrayBlockingQueue is. ArrayBlockingQueue is a standard type that's defined in Java that is used to provide a bounded buffer mechanism that limits concurrent access to a fixed number of elements, in this case, available locks, that are associated with a given lock manager. As you can see in the diagram on the right, there's several methods that are defined by ArrayBlockingQueue. You have the put method, which will try to put something into a queue, blocking if the queue is full. There's the offer method that's used to put something into a queue that will not block, even if the queue is full. It'll just return null. And then there's also another pair of methods called take and pull. Take will block if called on an empty queue, and pull can be used to check to see if there's an item in the queue, and it doesn't block. It'll remove an item if it's there, otherwise it will return null. All those methods are synchronized and thread safe, so different threads can call offer and pull and take and so on the same ArrayBlockingQueue at the same time. This is how we're going to implement our distributed semaphore. There's also a parameterized type that's used for ArrayBlockingQueue since it's a generic class in Java, and we parameterize it with lock, which is a type we define, which defines an object that clients can use as a lock in our distributed system. There's also the LockManager, which we use in conjunction with map to keep track of the allocated ArrayBlockingQueue objects associated with a given LockManager. And as you can see here, a LockManager has a name and a count of the number of permits or locks that it manages. And then we use a map type here to associate the LockManager with the given ArrayBlockingQueue that it's controlling or managing. And what we do under the hood is we auto-wire this LockManager map to a concurrentHashMap, which is a really neat type that's defined in Java that allows multiple threads of control to simultaneously do updates and removals and lookups and so on in the map, and do it in a very efficient way that works in a thread-safe manner in a highly concurrent program running on multi-core processors, which is what we're doing here. So that's the second field that's auto-wired in LockManager service. Now we have a number of methods defined here, the first of which is the create method, which is a factory method that takes in a permits count and returns a LockManager that implements a given distributed semaphore. each instance of LockManager is used to handle a different set of permits or locks, so we can deconflict and differentiate them. There's then a method called acquire. There's actually a couple of acquire methods, but the first method is going to use the Java array blocking queue that we just talked about in order to acquire a single permit or a single lock. And we'll take a look at the implementation details in the next part of the lesson. Notice that we use the @async annotation, and this marks this method as automatically being executed asynchronously by the AsyncTaskExecutor that we've auto-wired earlier, and it will run in a virtual thread, as we talked about earlier. And we'll look at this when we look at the implementation later as well. So this is a feature that's part of Spring. We then have a second acquire implementation that's going to take a LockManager, and it's also going to take a count of the number of permits that we want to be able to acquire atomically. So we're going to be able to acquire multiple permits or multiple locks. By the way, permits and locks are being used here interchangeably. This particular method, as you can see, is not marked with the async annotation. We're going to implement it slightly differently just to show you the variety of ways things work. If you take a careful look, however, you'll see that this particular method returns a deferred result, and therefore it's going to be able to offload the actual business logic of acquiring multiple permits from the incoming HTTP worker thread onto a virtual thread that we're going to create using our executor that we have auto-wired as a field. There's also a pair of release methods that use the Java ArrayBlockingQueue to return either one or more permits or locks to the semaphore. And we'll talk about that in more detail in upcoming parts of the lesson. You can see here that one of these returns one lock and the other is used to return a list of locks. Obviously, that list of locks would have been acquired using this version of acquire. So that walks through part 2 of the server structure and functionality in our LockManager app case study.